All right, let's talk about your next thermal inspection. You're investing in this powerful technology, so how do you make absolutely sure you get the best possible data? Well, it really just comes down to knowing the rules of the game.
I mean, really think about this for a second. What if you could see a massive failure weeks before it actually happens? We're talking about a critical motor overheating, a hidden roof leak that's destroying your insulation, or even just energy bleeding out of your building. Seeing it all before it turns into a complete disaster.
And that's exactly what thermal imaging can do. It's basically a superpower. But here's the catch. Like any powerful tool, it only works if you set things up just right. The success of the whole inspection, it really depends on getting the perfect conditions for a clear, accurate scan. And believe it or not, that's where you come in.
Okay, so first things first. Before we can even talk about the rules, we've got to understand what the camera is actually looking at. And trust me, it's probably not what you think.
So here's the key thing to wrap your head around. A thermal camera isn't really a thermometer. It's more like a light meter for energy we can't see. It's measuring the invisible infrared energy that literally everything around us is giving off all the time. The camera sees that energy, and then we translate it into a picture that we call an apparent temperature. And that is how we can suddenly see something like a loose wire overheating or a patch of wet insulation in a roof.
Okay, now we're getting to the heart of it. A really good inspection is all about one thing: separating the signal from the noise. The signal is the real, true thermal data coming off your equipment. The noise? Well, that's all the other stuff in the environment that can mess up that data and give us a bad reading.
You know, it's kind of like trying to have an important conversation in a really loud, crowded room. The whole goal of a good inspection is to turn down all that background noise so we can clearly hear the whisper of a problem starting. And to do that, we need to get a handle on three really important things.
So the first one is a bit of a sciencey word: emissivity. But don't worry, it's actually pretty simple. All it means is how well a surface gives off its own heat. Something with high emissivity, think concrete, or anything with a coat of paint, it's like a clear speaker. It tells you its true thermal story. But a low emissivity surface, well, that's a whole different ballgame.
And yeah, that brings us right to our second big variable, reflected apparent temperature. This is a massive source of that noise we were talking about. If you're looking at a surface with low emissivity, like a shiny piece of metal, it basically acts like a thermal mirror. So the camera isn't seeing the temperature of the metal itself, it's seeing a reflection of the cold sky, or maybe that hot machine running right next to it. It's totally misleading.
And last but not least, and for anything electrical or mechanical, this one is absolutely crucial, is load. Think about it. A loose wire might look perfectly fine when there's barely any power running through it. But you crank that system up to full load, now that bad connection creates resistance, it generates heat, and suddenly that fault just lights up on the camera. If you inspect a system when it's not working hard, you're just asking for a false negative. You'll miss a huge problem that's just sitting there waiting to happen.
So check this out. This shows you the difference perfectly. Over here, you've got a good target. It's got high emissivity. Maybe it's painted or it's concrete. It gives us a clean, reliable signal. It's telling the truth about its temperature. But then you look at this other one, the bad target. It's shiny, low emissivity metal. It's just a total mess of reflections. It's literally lying to the camera. And a good inspector has to know how to see through that.
Okay, so with all that in mind, what's your role in all this? Well, it's huge. The quality of that final report you get is directly linked to the prep work that happens before the inspector even shows up. So let's run through your pre-flight checklist.
All right, these three things right here, they are absolutely non-negotiable. First, you've got to maximize the load. Run your equipment hard. We're talking over 50% of its normal capacity, so that any problems have a chance to heat up and show themselves. Second, for buildings, we need a decent temperature difference between inside and outside, what we call a delta T, so we can actually see the heat escaping. And number three, probably the simplest one, everything has to be dry. Rain, dew, frost, they create their own thermal patterns and can completely hide the real issues underneath.
And hey, it's not just about the physical conditions. The information you provide is just as important. Your inspector needs to know the exact load data, like the amps or the PSI, to really analyze what they're seeing. And of course, they need clear, safe access to everything. Plus, having things like electrical diagrams or maintenance logs on hand, that's what helps them turn a random hotspot into a specific diagnosis, like, hey, it's this exact breaker that's about to fail.
Now, for something that might surprise you, you could have all the conditions perfect. The load is right, it's dry, but if you do the scan in the wrong time of day, the data can be completely worthless.
Seriously. Timing isn't just a suggestion. It's a hard and fast rule that's dictated by physics.
And this table here breaks it down perfectly. Look, for something like a roof inspection, we have to do it after the sun goes down. Why? Well, the sun bakes the roof all day. Then, as it cools off, the dry parts cool down fast, but any wet, trapped moisture holds onto that heat way longer. Boom, that's how we see the leaks. For a building envelope, we want that big, stable temperature difference, which you're going to find late at night or right before dawn. And for electrical and mechanical stuff, we've said it before, but it's all about hitting it during peak operational hours.
So knowing all that, when is the data just completely useless? What are the absolute deal breakers? The things that should make you and your inspector look at each other and say, nope, not today, we have to reschedule.
Here they are. These are the big red flags. If the wind is blowing consistently over 15 miles per hour, forget it. It's just stripping the heat off the surface and hiding everything. If the sun is shining directly on what you're trying to inspect, that solar radiation will completely overwhelm the tiny signals we're looking for. Rain, frost, dew, we've talked about that, it's a total data killer. And finally, if you can't confirm what the operational load is, we can't really say how severe a problem is. Any one of these is a showstopper. You just have to postpone.
All right, so you've done it. You've nailed the prep, the conditions were perfect, the inspection is done, and that report is sitting in your inbox. So, now what? Let's talk about how to decode that report and turn all that data into a real plan of attack.
You know, what's great is how straightforward this can be. For electrical gear, it really just boils down to delta T. That's the temperature difference between your hotspot and a similar normal component right next to it. If it's just a few degrees hotter, okay, let's keep an eye on it, maybe fix it at the next scheduled shutdown. But if you're seeing a 4 to 15 degree difference, that's a high priority. You need to investigate that soon. And anything over 16 degrees, whoa, that's critical. That's a shut it down now and fix it kind of problem.
So at the end of the day, that report you get, it's not just a bunch of cool-looking pictures. It's a roadmap. It's a prescriptive tool that uses industry standards to tell you exactly where your biggest risks are, so you can point your maintenance team, your time, and your money at the problems that matter most.
And really, that's the whole point, isn't it? The inspection is done, the report is in your hands, you can now see the invisible. So the only question left is, which of those risks that you didn't even know you had yesterday are you going to eliminate tomorrow?